Right, the last question, 4.2.3. Let's get straight into it. So don't get confused because you see something like this. This is still very simple. In fact, let's do this. The sine thing, okay, sine of x. Let's go and replace it. Let's go call it something else. How about k? Is k from now on, okay? So what do you actually have here? You have 2k squared plus 3k, and you have a minus 2 there, and this is all equated to 0. This is simple, this is basic, this is a simple quadratic that you can factorize. Here's a 2 here, so that tells you it's an advanced trinomial. That simply means that you have to consider these factors as well as these factors, and this is easy because both of them are prime, so your only factors are 2 and 1. So let's go for this, 2 and 1, and 1 and 2. One of the sides we double up, and then we're going to say 1 and 2 on the side. If you don't know how to do your factorization, then you're going to have to go back to my videos where I deal with factorization. Okay, so we're going to multiply across. We're going to try and get our middle value here. So 1 multiplies with 2 to give us 2. 2 multiplies with 1 to give us 2. Can that get me my middle term? No, 2 and 2 can't get me a 3. So that did not work. So let's go on to the next one. 2 times 2, that's going to give me a 4. 1 times 1, that's going to give me a 1. Yeah, that can get me a 3. I need a positive 3, so the 4 needs to be positive, 1 needs to be negative. Seems easy enough. Alright, so this is going to give me 2 brackets. Inside my brackets I'm going to have, so I need a 2 and a 1, so a 2 and a 1 and k, so this 1 is invisible obviously, and the 2 multiplies with the 2, so the 2's have to be in opposite brackets, so that one goes there because this one is here. The 1 multiplies with the 1, so the 1's have to be in opposite brackets. I need my 4 to be positive. The 2 multiplies with the 2 to give us the 4, so that has to be positive, that has to be negative. Again, if you can't factorize, go back and look at those videos. So we don't actually have k's in our question, so let's go back and replace your k with sine of x. So here what you have is you have 2 sine x, that is sine x minus 1, and your other one is sine x plus 2. Okay, and both of these are equal to 0. So because it's equal to 0, you know that this produces a solution and this produces a solution. This one is going to be 2 sine x minus 1. This is maybe 0, or this is 0. Okay, let's manipulate this over here. So we're going to add 1 on both sides. So this is going to be 2 sine x equals 1, divide 2 on both sides. I forgot my x over there, just put it in there, divide by 2 on both sides. So our left hand side over here is going to be, let's write it over here because we're going to use quite a bit of space, sine of x equals a half. Alright, and then the side over here, that's going to be sine x plus 2 equals 0, and then take the 2 over, or subtract 2 on both sides, so that's gonna reduce to sine x equals minus 2. Okay, so we can even on this side, let's discuss this one first and then we'll go to these solutions. This we discard immediately, right? So here you will say x is equal to no solution, right? Why do we say that? Okay, no solution. We say this because there's no values of x that can produce a 2 or a minus 2. We know how the sine function looks, the mother graph if you want to call it that. Sine function looks like this, right? Which repeats itself. The highest that it goes is 1, the lowest that it goes is minus 1. So there's never a time when sine x actually reaches minus 2, so there's no solution that meets that requirement. Okay, so this side, no solution. This side over here, this will produce 2 solutions, right? Same like the general equations which we did in the previous 2 videos. So we are dealing with sine x equals a half, so we'll say sine C-A-S-T cost, right? Sine positive, so we are in first and second quadrant, so let's go find our reference angle. Our reference angle is going to equal to arc sine of a half. That is one we should know, right? Arc sine of a half. I'm going to use my calculator, but I think we should know that that is going to be 30 degrees. If you don't know that, we know that from our special triangles. I think I might have made a video on that for the grade 10 special triangles, so go check that out. Okay, anyway, sine x equals half, so x has to equal to 30 degrees. This is our reference angle. We are in the first quadrant, so let's get the first quadrant solution, and then we're also going to be in our second quadrant. So first quadrant, x is going to equal to 0 plus, right? So our 30 is going to be that solution, plus k times 360, and we need to say that k is an element of integers. Alright, so that is done. There's no manipulation required here. That is the solution in that quadrant. Second quadrant is 180 minus. So 180 minus our reference angle. Our reference angle is 30. Again, k times 360. Okay, we don't again have to say k is an element of integers. We already said that. 180 minus, that's going to be 150 degrees plus k times 360. Okay, great, easy. The only difference was you first had to factorize, so just some grade 10 work over there. Your advanced trinomial had to be factorized. Once you did that, then you found these two solutions. In this case, we could throw this one away because that value was too far, but if that was not a value that was beyond the range of your sine function, then that would have also produced two solutions. So possibly you could have had 4 solutions for this question. Okay, but our left hand side was valid, and that gave us these two solutions over here. Great.